In this video, we discuss the ecological transformation of over 7,500 lakes in western Greenland. This change is attributed to extreme climatic conditions. A new study marks the role of atmospheric rivers in this transformation. Atmospheric rivers are narrow regions in the atmosphere that transport amounts of water vapor. They have a deep impact on weather patterns outside the tropics. In September 2022, western Greenland experienced unusual climatic events. Record heat was followed by heavy rains due to atmospheric rivers. These conditions altered the biogeochemical, physical, and biological features of the lakes. Lakes are crucial in the Arctic landscape. They facilitate the mineralization of organic carbon derived from land. The study, published in the Proceedings of the National Academy of Sciences, warns of risks to over 3.5 million lakes at higher latitudes. The climatic extremes in September 2022 led to temperatures remaining above normal. Most precipitation fell as rain instead of snow. By the end of September, remnants of Hurricane Fiona brought additional warmth. This resulted in record melting of the Greenland ice sheet. In July 2023, atmospheric rivers caused the wettest and warmest July since 1940. The increased heat led to the thawing of permafrost. Permafrost holds amount of organic carbon. The thawing released carbon, iron, magnesium, and other elements into the lakes. This influx of materials altered the lake's physical features. Remote sensing data indicates that a large area of western Greenland was affected by these storms. Wetter soil conditions from autumn 2022 and summer 2023 led to a mosaic of terrestrial greening. This was reflected in higher normalized difference vegetation index readings. As a result, the average concentration of dissolved organic carbon in the lakes increased by 22% compared to averages from 2013 to 2022. The lakes, once blue, became darkly stained brown within a year. This phenomenon is comparable to changes observed in boreal lake history over thousands of years. The browning of the lakes reduced light penetration by 50%. This alteration in physical and chemical properties decreased biodiversity in plankton populations. The changes severely impacted the region's carbon cycle. The study noted shift in the lake's role. They transitioned from being summer carbon sinks to sources of carbon dioxide. There was a more than 350% increase in carbon dioxide flux from the lakes to the atmosphere. Additionally, methane concentrations were 72% higher in August 2023 compared to 2014. The scientists warned that long-term ecosystem transformations could have serious ramifications. They cited the example of the 1861-62 winter mega flood in California. This event caused extensive flooding and long-term drought, leading to economic impacts. California faced a 25% loss of its economy and ultimately declared bankruptcy. The transformation of western Greenland's lake ecosystems persisted through the summer of 2024. It remains uncertain if and when these lakes will revert to their original blue state. The study indicates that while in their darker state, these lakes are larger sources of greenhouse gases. Tens of thousands of lakes in western Greenland were affected by these climatic extremes. The deterioration of water quality has direct implications for Greenlandic communities. Many of these communities rely on lakes for drinking water. The changes have affected the taste and caused odor problems. They also pose multiple health risks to the local population. The scientists concluded that the lake ecosystems of western Greenland have crossed a tipping point. This change is a direct result of compound climate extremes. The findings tell the importance of integrating potential ecological surprises into future planning and adaptation strategies.